everybody, welcome to another Innovation Series demo. And in today's demo, I want to introduce you to a pattern that I love and use very often. What we're doing is building a server function which both improves security, performance, and developer experience. And it's currently released, so you're welcome to do this in production today. So generally, the pattern looks something like this. You have a server function or a client that needs to access a token. And so you create a custom server function which basically produces a token. And what you do with the server function is you actually manage the token inside Vari. So this server function will obtain a token and put it in Vari. It will save the expiry, and then basically once the token has expired, it will go and fetch another one. And if the token has not expired, it can return the token. You can level this up one step further if you know that these tokens are going to be used strictly within poly functions, and you can actually return the .inject reference. So this is actually really nice because if you do this whole pattern as depicted here, you end up improving security because these tokens are never actually handled by your integrations or server functions. They're never handled by the clients. All that's being handled is that reference to a token, which means it can be used in functions, but it significantly limits the scope of where this token can be applied. Secondarily, it reduces load on the authorization service, so that kind of bottom API function for getting tokens represents your authorization service, and so this is only used when the token has actually expired. But it also improves performance because you're passing a cached reference to a token instead of going and obtaining one. So even if you're using a vault, even if you're caching your tokens, you still end up avoiding one extra call because Poly kind of injects it at the time of processing it. So that speeds up performance as well, eliminating kind of one round trip. And then lastly, you end up improving the developer experience because now when you're building these server functions or your clients and you need a token, you basically just ask for a token kind of in every function, meaning you don't have to worry about managing the token, kind of saving it, persisting it, etc. You can just say, give me a token. And that function will either give you a reference to an existing token, or it will go ahead and update that token and still give you a reference. So from your perspective, that's basically really nice as a client developer. And you can imagine that if you're using this across many different integrations, it really simplifies the code of each of those integrations and at the same time ensures that you have security best practices. We highly recommend that you make this a server function, not a client function, so that the code is kind of invisible to the client and integration developers. And generally, this should be built by somebody who really understands kind of the security domain really well, and to ensure that you're using kind of best practices. And then by doing this right, you can basically allow the client developers to just inherit those best practices by virtue of using this function. And the big innovation that makes this possible is kind of Vari, the service itself, and especially the .inject, which allows you to basically pass those tokens by reference. And our vision here is a little bit fuzzy. We have some ideas on kind of how to level this up. And so two areas you'll discover in using this. One is that, if you have an expiration that you're checking, today you have to model that as a separate variable, which is kind of annoying. It'd be nice if that same secret variable that possesses the token could also have kind of non-secret metadata about the token. So today, by virtue of the token being a secret and you needing to be able to actually read the value of the expiry time, you have to split them up as two. So I think there's a little optimization we can do there. And then secondarily, the kind of app-specific registers. So today, you kind of have to do this function on a per client basis, or this function needs to take in some kind of client ID or identifier that allows it to manage separate tokens for separate function or separate clients. So in that case, you have to be really careful with the Vari. You either need to model out separate variables representing each client, or you need to kind of create a variable that can store tokens on behalf of multiple clients, but you got to be really careful to pull the right one to ensure that you don't cross-contaminate the tokens. So there is a little bit of a nuance here that would be really nice if it was just kind of implicit. So what we're thinking of is maybe in the future there could be variables that have a kind of client, implicit client tenancy to them or register, where depending on the key used to invoke the function, you can just kind of implicitly access the right configuration, or in this case token. So there's another optimization there that I think would make this even more elegant. So with that, let's go take a look at how this function was implemented. So here we have an example of a function that I built. I'll go ahead and just kind of walk you through it so you understand the logic behind it. So again, this function was built specifically to represent a single client, so there would be a little bit more work to kind of refactor this to support multiple clients. But generally what you do is you basically establish the current time, and then you would fetch the expiry time for the given token, and then you would compare that against the current time, and you could set some limit on, hey, if it's going to expire within X amount of time, maybe it's just best to get a new token to avoid a situation where it just kind of runs out on the user while they're using the app or while the integration is running. So in my case, I went ahead and set that to 3 minutes. And so here, basically I throw an error saying, hey, it's too close or it's already expired. Let me go ahead and fetch a new token. However, if it's not expired, we basically return the .inject reference. So this is an object that basically Poly knows how to interpret to just in time inject the right token. And so you're welcome to actually pass these objects around, as I'm doing here in this situation where the server function actually gives you that reference. So we catch the error, and so what we do here is we basically go ahead and process a get OAuth token. So again, here I'm using Kroger's client credential endpoint to get the token. And what this expects is a client secret and client ID. And so here I'm basically passing them as .injects. So as you think about potentially refactoring a function like this, you could actually ask for .inject references to client ID and client secret, which would ensure that there's never any credentials being passed even between the client and this function. So that would be a really nice secure way to basically pass your credentials by reference, assuming you're using Poly for executing the functions. And then down here, what we do is we go ahead and get the new token from that response. We calculate the new expiry time, and then we go ahead and basically do a promise all to update both of those variables. Like I said, ideally this should be kind of like a secret with some visible metadata. We don't have that construct today, so I'm modeling it out as two variables, one representing the expiry time, one representing the actual token. The one that's the actual token is a secret, which means you can't actually access it or log it within this code. So that's also kind of really nice, but you can update it. So because we use the function to get it, we technically do have the token here. And so you're allowed to update secrets, but if anyone else anywhere wanted to read it, they couldn't. And yeah, that's it. And then we pass that same return reference to the token in this case. So with that, hopefully you enjoy this demo. Like I said, I really encourage you to use this pattern because it actually really both improves performance, developer experience, and security. And we see that as a big win because everybody benefits across the spectrum. So thanks so much and have a great day.